Nice. So Newton's method, this is your project. Again, you can work on it in a group of 3 maximum. If you take a look at the project right now, the one I handed out to you, and you look at part F, you'll see part F has 3 pieces to it. All 3 of those pieces, this method of finding roots is going to fail in part F. So if you're working alone, just do one of those pieces. If you're working in a group of 2, do 2 of them individually. If you're working in a group of 3, do all 3 of them, but each of you do 1 of them individually, right? So let's talk about what Newton's method actually does. Newton's method is used to find roots. So there's my solution. So I'm going to use Newton's method to find roots, or x-axis, or zeros, right? X-intercept, sorry. Yes, you with me? So this method is a process using a derivative to find that root of the function. So what we do is we're going to guess. So x sub 0 we'll call the initial guess. So I'm going to guess at the solution. I'm going to try and get close when I guess, but sometimes you can't. Like if the answer was pi, what would be a good guess? Well, that would be pretty good. That'd be real close. 3 is a good guess, right? We're going to try and guess somewhere that is easy. So I'll guess 3 first. So what happens is I go up to my function. I go up to the function, and I draw the tangent line. And where it hits is my next guess. So I start somewhere, make a guess, right? If I'm right, I'll be done. If I'm wrong, I go up to the function, draw the tangent line, and that tangent line is going to hit closer to the root that I'm looking for. Sometimes not, and again, that will be in part F of the project. So there's my next guess. Now, let's see, what do I have here? I have x sub 0, f of x sub 0, right? And what about this point? Where is this point? Anybody know? Where's my x sub 1 point? X sub 1 comma what? What's 0? Yeah, it's the height, right, of the tangent line hitting the axis, right? Yes, you with me? Yeah. So I can get my equation of my tangent line, right? So it's y minus f of x sub 0 equals f prime of f of x sub 0 times the quantity x minus x sub 0, right? I'm just using this one point here to get my whole tangent line. Yes? Agreed? No? Remember we had y minus f of a equals f prime of a all times x minus a. So I'm just using the point that I initially have on my curve as the point I'm using for my tangent line. But what do I know about y and about x? Do I know anything about y and about x? Say yes. Y is what height? 0. And this x is my x sub next. That's my next guess. Okay, and this is my language. When you read the book, so you're reading section 4.7, or you're going to YouTube to look at your favorite nerd talk about Newton's method, right? And that's part 1 and 2 is I'm doing part A and B. Right now, if you read this, you're like, oh my God, what the hell is this saying? But part A and B is what I'm doing right now, okay? So I want to solve for x sub next. So I'm going to divide by f prime. And then I want to add my initial guess to the other side. So I get x sub next equals my initial guess minus the function evaluated at the initial guess divided by the derivative evaluated at the initial guess. And this is Newton's method. And what we do is we iterate, meaning I make a guess, I get an answer. Take the answer, put it in as my next guess. Okay, get an answer from that. Take that answer, put it in as my third guess, second guess, fourth guess, right? Until I get closer and closer to the solution. How are we doing so far? Good. Let's look at part C. Now I'm gonna go up to part C. Okay, I'm gonna go up to part C, and then you should be able to do part D yourself. Part E is the difficult piece. So just letting you know right now, part E is all algebraic, no numbers. Okay, part E is all algebraic, no numbers. I will talk about part E later in the semester. So it says I have a function here in part C. Well, I have two functions. I have y equals 1 over x and y equals 1 plus x cubed. And I want to find the positive point where they cross. And it's about 0.7. So that's where I'm going to guess. I could guess at 1. I could guess at 0.5. Right? So if I put those in Desmos, y equals 1 over x. Oops. And y equals 1 plus x cubed. And so Desmos gives me, what, 0.724. It actually is a never-ending, non-repeating decimal, but, you know, can I change my decimal places? I don't know if I can change my decimal places, but you'll see when I get my answer in Excel, you'll see that 0.7, what was it again? 0.724? Yeah, you'll see that 0.724 repeating over and over in my Excel file. Okay, and then I know I'm there. I know once it starts to repeat, I know I've got the answer, right? So we got to do a little bit of work here. First of all, we're going to create a function to get a 0. So I like f of x is 1 plus x cubed minus 1 over x. Right? Notice I took the two functions and got them on the same side, right? And that's my function now that I'm going to use. What's f prime? Three 3x squared plus nice 1 over x squared. If you remember my formula, x sub next, it's x minus the original function over the derivative. And before I go to Excel, I want that to be as clean as possible. I want this to be as clean as possible. So I'm going to get rid of my interior fractions first. Everybody with me? Oops, sorry. So I'm distributing in that x squared, right? So I got now what, x squared plus x to the fifth minus x over 3x to the fourth plus 1. Yes, you with me there? Somebody say yes for me so I don't have to look. Thank you. And I want to get an LCD. I want to make it as simple as possible before I go into Excel. And like I said, if you're somebody who's doing Python, you could do this on Python. It just has to be someplace that I can go without having to log in, right? So, so you certainly can use any language you want, as long as I can see it, right, and run the code. So I need x times 3x to the fourth plus 1 minus x squared plus x to the fifth minus x all over 3x to the fourth plus 1. So just going to simplify this as much as I can. So it looks like 2x to the fifth minus x squared plus 2x all over 3x to the fourth plus 1. Anybody, make sure you get the same thing from me before I go on and make a mistake. Say again? Of course. And I'm recording it, so you can go back and watch it, right? Yep. How we doing? Anybody else get the same? Anybody do it on their own and get the same as me? Chrissy, did you? Yes, thank you. All right, I'm going into Excel. I'm going to build an iteration, right? You can do this with any language that you know. You could do it with what's the Google version of Sheets? Is it Sheets? Yeah. Yeah, it's in the project. It's part C. So here's my iteration idea. I'm going to start at 0.7, right? And you see I've got an iteration already built, but I'm going to redo it, okay? So in here, I want to type equal. Now my original guess is in cell A1. Do you see that? Column A, row 1 of Excel. So that is my new X, capital A1, right? So I have what? I have 2x to the fifth. So equals 2 times A1 raised to the fifth power. So that capital A1 is my X value, right? You following me there? So, and I wish I could get this bigger, but I can't. That one cell won't get bigger where I'm typing it in, but I'll write it in on my pad in a second, okay? Minus x squared. So minus A1 caret squared plus 2x. So plus 2 times A1. All of that I want in parentheses, right? All of that in parentheses because that's my numerator, yes? Divided by parentheses, right? What was it? 3x to the fourth plus 1, right? So 3 times, yep, 3 asterisk A1 raised to the fourth plus 1. So look at what I got at a guess of 0.7. Yes? At the guess of 0.7, I got 0.724. 0.37, right? Desmos just gave me 0.724, so pretty damn close right away, right? Now, I want to do this. I want to take my answer that I just got, which was B1, and put it into cell A2, right? So I'm going equals B1. And then I'm going to fill down from row 2 down on the first column. Control D will fill down. And I want to fill down from row 1 down in column B. And look at that. So it took my 0.7, right? And got me 0.7437. Then I took 0.7437 and made it my new guess. And then I put that in, and I got 0.7449. In fact, I never got anything different after that. So it took 2 iterations to get me the answer. It only took 2 times. Go ahead. Mom, you gonna say something? Is that making sense? So what I'm doing is I'm picking a point, grabbing the tangent line, it hits the x-axis, and I start again there. Pick that point, go up to the function, get the tangent line. Usually it will crisscross back and forth until it hits. All right, so you can start the project. I am planning on giving you that Monday of Thanksgiving week to do the project. So if you're here for another class, your group can meet at this time in the library or computer lab, right? I've had in the past a couple of pretty strong students finish it in 2 hours. So it is possible. And if you're working with a group of 3, I would imagine if you divide and conquer a little bit and then get together and discuss, shouldn't be too long. The tricky part is part E, and I will talk about this later this week or next week. Part E is all algebraic, okay? So, meaning no numbers, no iterations. So in part C, you're doing iterations. In part D, you're doing iterations. In part C, you're just doing algebra. Part F, you're doing iterations and graphs. All right, have a great day.